use the ideal gas law to also figure out how much product, gaseous product, will be made in a chemical reaction. Here is an example. When zinc reacts with HCl, what are the products? Well, that we've done before. We have zinc reacting with HCl. Those are the reactants. Since I have a singular element reacting with a compound, this is going to be a single replacement reaction or single displacement reaction. And I will get the zinc next to the chlorine, or with bonded to the chlorine. Zinc is always a 2+, and chloride is a 1-. So when I crisscross, this product will be ZnCl2. The hydrogen will be knocked off of that compound, and the hydrogen will be the singular element, and hydrogen can't be by itself, so it has to be H2. You don't have to know this, but we actually did a reaction like this in a lab a while ago, where gaseous hydrogen was produced. We trapped that in a test tube and tested it, and there was a big pop when we introduced a flame. This was aqueous, as well as the product was aqueous, and the zinc was a solid chunk that we put into that aqueous HCl. Anyway, so there's our chemical equation. Now we need to make sure it's balanced. And so I start with 1 zinc, I end with 1 zinc. I start with 1 hydrogen and end with 2, so that means I need to have a coefficient of 2 here. That's 2 hydrogens balancing out those 2 hydrogens, and 2 chlorines balancing out these 2 chlorines. So we have a balanced chemical equation. Perfect. Now I'm going to gather my information about that reaction. 4.5 liters of hydrogen were produced. So the volume of the gas, now that's the thing about the ideal gas law, is that all of the information that I'm going to gather for my ideal gas law has to be about the hydrogen, because that's the only substance that is a gas. Okay, so the volume of that gas that was produced was 4.50 liters. That's a decimal, not a, okay, 4.50 liters. It was produced at a temperature of 30 degrees Celsius. I don't want Celsius, so right away I'm just going to add the 273 to make it easier to calculate. That'll be 303 Kelvin. It was collected at a pressure of 722 millimeters of mercury, and as we have worked with in the past, that millimeters of mercury doesn't really match the constant that I'm going to be using. So I want to convert 760 millimeters of mercury are in 1 atmosphere, or are equivalent to 1 atmosphere pressure. So that will cancel those units, and I will get a little bit less than 1 atmosphere, or 0.95 ATM. And that is all of the information given in the problem. I'm supposed to find how many grams of zinc, this is what I'm going to be looking for, that are required to make this much hydrogen. Okay, well, I can't use any of the ideal gas law information with zinc, because zinc is a solid. And so I'm going to have to focus on the hydrogen information first. So I have a volume, I have a temperature, I have a pressure. I always have the constant. The ideal gas constant is 0.0821. That's ATM times liters over moles times Kelvin, which is why I need to have all of my units matching. My temperatures have to be in Kelvin, my volume has to be in liters, my pressure has to be in ATM, and that will allow me to find number of moles of the gas, which is H2. So I'm going to write down my ideal gas law. PV equals nRT. I'm going to find the number of moles of gas by dividing both sides by R and T. If I divide both sides by R and T, R divided by R is 1, so that cancels out. T divided by T is 1, so that cancels out. And I get N equal to all the rest of my variables. So I have pressure, 0.95 ATM. I'm not going to put the units in there. I'm just going to put my numbers, but because I already checked the units match, 4.50 liters divided by the constant, 0.0821, divided by the temperature, 303, should be equal to my number of moles. My number of moles, then when I calculate, plug all that in, I get 0.17185 moles of H2. Okay? That's not what the question asked me for, though. The question asked for how many grams of zinc. But now, since I know the moles of H2, I know that for every 1 mole of H2, here's a coefficient of 1 that I don't have to write down, and it comes from 1 mole of zinc. So in my next factor, I'm going to have 1 over 1. This is moles of H2 on the bottom. This is moles of zinc on top. So my moles of H2 cancel. Well, that's how many moles of zinc then I would have, but it asks me for how many grams. So I need one more step, and I put moles of zinc on the bottom, and I want to get to grams of zinc. Anytime I go from moles to grams or grams to moles, it's always 1 mole. I go to the periodic table and I find 65.39 grams of zinc for every 1 mole of zinc. If I calculate that, I get 11.237. Then I go back to my problem and I look at my sig figs. Here are 3 sig figs. This only has 2 sig figs, but when I add my 273, my temperature ends up having 3 sig figs. My pressure had 3 sig figs. I actually probably should have kept a little bit more there. That's actually my mistake. You should keep a little bit more. I can't remember if there was a 0 there or not, but that has 3 sig figs. So my answer can be rounded to 3 sig figs, which is 11.2 grams zinc. Box your answer. You're good to go.